Okay, I'm going to look at the rate, how increasing rate we can predict whether it doubles or triples or whatever. So here I've got this expression where my initial rate is equal to Ka. So what if I double A and make it twice as big? Okay, so K2A, I'm going to make it K2A. So I'm going to rearrange this equation, and it's twice the concentration. So I'm going to take the 2 out of the bracket, and I'm going to multiply it by K and by the concentration of A. But R1 equals Ka. So I'm going to substitute into this equation, so it equals 2R1. So if I double the concentration of A, I double R1. Let's have a look if A increases to 4 times as much. So K4A, I'm using 4 times the concentration of A. So so this is 4 times the concentration of A, so K is 4 times the concentration of A, which is 4Ka, and we know that Ka equals Ka equals R1, so it's 4R1. So we can see that the rate increases by 4. So we've actually got a linear relationship. So as we increase the concentration of A, the rate will increase by the same amount. Okay, so I'm now going to look at a concentration B, and this rate equation is second order with respect to B. So what does concentration squared mean? It actually means concentration of B multiplied by the concentration of B, so B squared. So what happens to the rate if I double the concentration of B? So basically, if I've had a 1 mole per decimeter cubed solution of B, what happens if I go to 2 decimeter cubed solution? So I'm going to rewrite this again. So I'm going to say K is, so the concentration is twice our initial concentration. So I'm using 2 times the concentration of B. So what does this actually mean? So K is 2B times 2B. Okay, so I've got twice the concentration of B and twice the concentration of B. So 2 times 2 is 4, and B times B is B squared. And if I rearrange this, I've got 4K B squared. I can see that this is the same as our initial rate, call it rate 1, so it equals 4 times rate 1. So if I double, so if I double the concentration, the rate increases by 4, or 2 squared, or by 2 squared. Let's have a look if I tripled. so triple the concentration. So I'm going to use 3 times the amount of B. So I've got K 3B squared, which means K is 3B times 3B times 3B. So 3 times 3 times 3 equals 9, and B times B times B is equal B cubed. If I rearrange this equation, 9K, oops, what have I done? Take that one out. So it's K 3B times 3B. So 3 times 3 is 9, and B times B is B squared. And I can just take that outside the equation, and we can see that KB squared is the same as our initial rate back up here. So we can substitute KB squared for rate 1. So it equals 9 times rate 1. So basically, as the concentration increases by 3, the rate increases by 3 squared, which is 9.